myself, Professor P A Gaikwad, Assistant Professor MPSC College, Panvel, Department of Chemistry. I am teaching one of the article of SYBSC syllabus, that is chemical bonding. So in that chemical bonding we see important article, that is hybridization. So we see SP3 dehybridization. So what is SP3 dehybridization? So here the mixing of one 3s orbital with 3p orbital and one 3d orbital to form 5 equivalent hybrid orbital. Such a process of hybridization are called as SP3 hybridization. So in that SP3 dehybridization, one 3s orbital, then 3p orbital and one 3d orbital are mixed together, and it can produce total 5 sp3 d hybrid orbital, and such a process of hybridization are called as sp3 hybridization. The most important example of the sp3 dehybridization is phosphorus pentachloride PCl5. Here phosphorus is act as a central metal and 5Cl is act as a ligand. So phosphorus has atomic number 15, its electronic configuration is 285. That means its outer orbital contains 5 electrons. As the reacting chlorine atom approach phosphorus atom, it forms 2 covalent bond. The energy release promote one of the 3s electron to vacant 3d orbital. This results in the formation of 5 half-filled orbital in the excited state of phosphorus atom. These 5 orbital, that is one 3s orbital, 3p orbital and one 3d orbital are assumed to hybridize, that is sp3d hybridization, and form 5 hybrid orbital. Each hybrid orbital of phosphorus overlap with half-filled 3p orbital of chlorine and form 5 sigma covalent bond. So here 5 sp3d orbital which are half-filled. So these half-filled sp3d orbital is overlap with 5 half-filled p orbital of chlorine, and it can produce 5 covalent bond, and that bond are sigma covalent bond. There is no any lone pair of electron, therefore PCl5 molecule has a trigonal bipyramidal structure. The equatorial chlorine atom at 120 degree and 2 apical chlorine atom are 90 degree. So the geometry of PCl5 molecule is trigonal bipyramidal. Trigonal, that means there are 3 bonds are equatorial and separated by bond angle 120, and 2 bonds are apical, and these bonds are separated by bond angle 90 degree. Then second type of hybridization is sp3 dehybridization. sp3 dehybridization. So the definition of sp3 dehybridization is the process of mixing of one 3s orbital with 3p orbital and 2 3d orbital. It forms 6 equivalent new hybrid orbital. Such a process of mixing are called as sp3 d2 hybridization. The example of sp3 d2 hybridization is sulfur hexafluoride, that is SF6. So here sulfur having atomic number 16, its electronic configuration is 286. So in the outer orbital of sulfur there are 6 electrons. The outer electronic configuration of sulfur atom is 3s2 3p4, and in the ground state it has 2 half-filled orbital. Sulfur shows covalency of 6, that is it forms 6 half-filled atomic orbital. This is made possible by promotion of one 3s electron and one 3p electron to 2 3d orbital. As the reacting fluorine atom approach sulfur atom to form 6 covalent bond. The energy release promote one of the 3s electron and one of the 3p electron in into vacant 3d orbital. In the excited state of sulfur atom, there are 6 half-filled orbitals. These 6 orbitals assume to hybridize and form 6 hybrid orbitals. Each hybrid orbital overlap half-filled 2p orbital of fluorine atom and form sigma covalent bond. So SF6 molecule has octahedral geometry with bond angle 90 degree. So these half-filled in SF6 half-filled SP3 D2 orbital is overlap with half-filled 6F fluorine ligand, and therefore here all the bond pair is formed. There is no any lone pair of electron, and therefore the geometry of SF6 molecule is octahedral and bond angle is 90 degree. Then another type of hybridization is SD hybridization. So here the definition of SD hybridization is when one s orbital and one n minus 1d orbital, that is 2 orbital is involved in hybridization to form 2 equivalent energy new hybrid orbital. Such hybridization are called as SD hybridization. Some alkaline earth dihalide involve SD hybridization. So alkaline earth metal involve such type of hybridization. Example, heavier alkaline earth like barium involve in SD hybridization. In barium dihalide, that is BaCl2, it has been proved that 5d orbital of Ba, that is barium, have lower energy than 6p orbital. Therefore, the energy required for excitation of ns2 electron to s1d1 configuration is much smaller, that is 110 kilojoule per mole energy, than the energy required for s1p1 configuration, that is 151 kilojoule per mole energy. Therefore, promotion of 6 electron is takes place to 5d orbital rather than 6 orbital. So barium having atomic number 56, its electronic configuration is xenon 54 6s2. In the excited state of barium, there are 2 half-filled orbital, one ns and one n minus 1d. These two are assumed to hybridize and form 2 SD hybrid orbital. Each hybrid orbital overlap with half-filled p orbital of chlorine atom and form 2 covalent bond. The molecule has a band geometry with bond angle 90 degree. So these SD hybridization are involved in barium dichloride molecule, and geometry of that molecule is band geometry having bond angle 90 degree. So thank you. We stop here.